Let's have a look at another assertion reason question. Here we have two statements. We will find both of these are right or not. In case both of them are right, whether the second statement is the correct explanation of the first statement or not. And these are the type of option in assertion reason questions. Now let's read our first statement, whether it is true or false. Assertion: two plane mirrors capped at right angles deviate any ray of light by 180 degrees after two successive reflections. Is this statement true? What does this statement say? We have two plane mirrors at 90-degree angle with each other. Let me draw the two plane mirrors like this. Shoo. So this is our plane mirror 1, tuck, 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 tuck. And this is the plane mirror 2, tuck, 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 tuck. Okay. Now, the statement said that they deviate any ray of light by 180 degree after two successive reflection. So let's take a ray of light, and the ray of light touches the first mirror like this. Bam. Now, if the mirror was not present, this would have been the direction of this light ray, right? Right. But we place the mirror. Now what will happen? Now the light will change its path. It will go like this. Wow. So light has changed its path. So there is some deviation of the light ray from the original path. And the deviation is measured by the angle of deviation, which is called delta. As this was our first mirror, we will call it delta 1. Okay? Okay. So we understand what do we mean by angle of deviation? The angle by which the light deviates from its original path is the angle of deviation. In this case, it is very easy to calculate angle of deviation. Oh, do you remember the formula of angle of deviation? Angle of deviation has the formula. The formula is 180 degree minus 2i for plane mirror, where I is the angle of incidence. Let me show you how do we get this formula. It is very simple. We can see this is the angle of incidence. We will call it I like this. This is I, right? Right. Now, this is the angle of reflection. And the angle of reflection is equal to angle of incidence, laws of reflection. So this will also be I. This will also be equal to I. So we can say the total angle like this by a straight line is 180 degree. So we can say delta 1 will be equal to 180 degree minus 2i. Can you see that? Yes, we can see. So remember this formula. This is very important. Now what happens? The reflected light after striking the first mirror, after coming from the first mirror, strikes the second mirror like this. So now this is our incident light on the second mirror, and this reflects like this. Okay. Now, can you tell me what is the angle of incidence over here? What is the angle of incidence right over here? Can you tell me what is this angle? You will say, sure, we can. How? See, that mirrors were at 90 degree, right? So the perpendiculars to these mirrors, the normals, will also be at 90 degree with each other, right? Now we can see a beautiful triangle, right angle triangle. One angle is 90 degree, another angle is I. So the third angle is 90 degree minus I. Yes, yes. Now this is the angle of incidence for the second mirror. And the angle of reflection, what will be its value? What will be the angle of reflection now? It is equal to angle of incidence. So this is equal to 90 degree minus I itself. Wow! We got all the angles in this figure. Now let me draw the angle of deviation over here. This is the angle of deviation. Can you see that? Yes. So let me call it delta 2. Come on, you can tell me what is the value of delta 2. Think about that. What is the value of delta 2? It is 180 degree minus 2 times angle of incidence. What is the angle of incidence for the second mirror? For the second mirror, angle of incidence is 90 minus I. Yes. So here we will write 90 degree minus I. Wow. Now let's add these two angle of deviation. Why are we adding them? Because see, this was anti-clockwise in sense and this is also anti-clockwise in sense. So we can add the two angle of deviation to get the net deviation. So delta net is coming out to be delta 1 plus delta 2. And you can see when I add them, 2 times of I will get cancelled out. And what are we left with? We are left with twice of 180 degree minus twice of 90, which is 180 degree. And 2I gets cancelled out. So delta net is coming out to be 180 degree. Okay, this is delta net. And you can see delta net is independent of I. This is independent of the angle of incidence on mirror 1. It is independent of I. So let's read the second statement. We just found out that the first statement was perfectly true. Second statement says, the above condition is satisfied only for the angle of incidence I is equals to 45 degree. No. This condition is satisfied for other angle also. It need not be the angle of incidence must always be 45 degree in order to satisfy this condition. If I is some other angle other than 45 degree, for example 60 degree, 30 degree, then also the total angle of deviation would be 180 degree. We just saw that the total angle of deviation was independent of I. So whatever I we want to take, we can take that. We will get the total deviation as 180 degree. So reason is false. Assertion is true. Reason is false. So these are the options. What should we pick? We can pick option C. Assertion is true, but the reason is false as the right answer for our question. Let's have a look at this beautiful question. Two plane mirrors are arranged as shown in the figure. Can you see the two plane mirrors? Yes, we can. What is the angle between the two plane mirrors? It is given to be 20 degree, right? A ray has been incident on one of the mirrors at an angle of 40 degree. So this angle of incidence is also given, right? Now the deviation produced in the incident ray after 3 successive reflections will be. So we are getting 3 reflections. This is reflection 1, bam. This is reflection 2, bam. And this is reflection 3. Oh, the third reflection is very, very interesting. See, they have given us an angle 90 degree. Can you see 90 degree? Yes. If this angle was not also given in the question, then we could have easily calculated that angle by applying the angle of incidence is equal to angle of reflection law, and then using the given data given in the question, this angle would come out to be 90 degree. But they have already given us this angle. So the third reflection is really, really interesting. In the third reflection, ray goes perpendicular to mirror 1 and strikes the mirror. What will happen? After this reflection, it will again return back. It will retrace its path. So after the third reflection, the direction of the ray is in the vertically upward direction. Can you see that? Yes. The angle of incidence for the third reflection is, what is the angle of incidence for the third reflection? Come on, you can tell that. Don't say 90, it is 0 degree. Angle between the normal and incident light is 0 degree. Angle of reflection will also be 0 degree and the light will retrace its path. Alright? Okay. Now we want the final angle of deviation after the third reflection. So some people do it like this. They take the angle of deviation after first reflection, angle of deviation after the second reflection, angle of deviation after the third reflection, and they add them by taking their respective signs. This is one way to solve this question, but we won't go with this way. We will have our own way. So our way will involve the two rays. Two rays are very important to get the angle of deviation. Which two rays? First, incident ray. So let's try to imagine what could have been the entire path of the incident ray if there was no mirror at all. So this is the direction in which incident ray was traveling. but we place the mirrors, and now finally the ray has changed its path. So after third reflection, what is the direction of the final ray? After the third reflection, we can see final ray is moving in the vertically upward direction. Can you see that? Yes. Now let's extend this, and we can see this is the final direction. Okay? Yes. Now the angle between them is the angle of deviation after the third reflection. Total angle of deviation after the third reflection. Okay? So this was the initial incident ray, and this was the final incident ray, and we found the angle between them. This is delta net after third reflection. Total angle of deviation after third reflection. So delta net, what is the value? Can you tell me the value? You will say very simple, very simple. We can see this angle is 40 degree. 40 degree is the angle between the incident ray direction and normal to the mirror, right? And this is also normal to the mirror. Oh, we can see that this angle is 90 degree, and this is the incident ray direction. So the angle between them is 40 degree, isn't it? Right? Right. Now the total angle, this total angle, let me draw a white angle. This total angle is 180 degree. Okay. So we can see delta net is coming out to be 180 minus 40. This is 140 degree, right? Right, exactly. And what is the sense? The sense is clockwise. So delta is in clockwise sense. I hope you can see that, right? So 140 degree clockwise. This is the angle of deviation. And we can mark option D, 140 degree clockwise, as the right answer for our question. Let's have a look at this awesome question. Two plane mirrors are inclined at an angle theta as shown in the figure. Can you see the figure? Yes. What is the angle between the two mirrors? Theta. Good. Now find the value of theta such that the light ray retraces its path after second reflection. So what is happening after second reflection? Light is retracing its path. Oh, light is retracing its path. So let's imagine a mirror, okay? Now at what angle should light ray fall on this mirror so that light retraces its path? Can you tell me which ray will retrace its path? You will say yes. Which ray? A ray which strikes perpendicular to the surface of the mirror will retrace its path. So if the ray is striking like this, it will go straight away back to its original path. Okay? Good, good, good. So this is how we can retrace the path. Now, for the first mirror, we can see that the ray is not falling perpendicular to the first surface. So after reflection, ray will go like this, and it will strike the second mirror, and it should strike the second mirror perpendicular to the surface of the mirror so that this light can retrace its path. So light will go back and hit the mirror 1, and again it will go and retrace its path. Right? Right. So this is the situation. Now we want the angle to be 90 degree. This angle to be 90 degree. Now let's cut our way aside the question. Let me ask you a tricky question at this point. Now, what can you say is the angle of incidence on the second mirror? What is the angle of incidence on the second mirror? Did I hear 90? No, 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 it is not 90. It is 0 degree. Remember, angle of incidence is measured from the normal. Oh, it is 0 degree. Yes, yes, yes. Now let's get back to our business. Let's quickly find the value of theta. So here we can see this is our light. It strikes the mirror like this, and we can see it will retrace its path back. Nice, nice. So this angle is 90 degree. What do you think is the value of this angle? What is this angle? You will say this is 90 degree minus theta. Good, awesome. And what was the angle of incidence on the first mirror? What was the angle of incidence? You will say that is simple. So we can see that this angle is 60 degree. Good, nice. And what is the angle of reflection? Well, if the angle of incidence is 60 degree, angle of reflection got to be 60 degree. Nice. So this angle is 60 degree. Now can you see something wonderful? I will tell you. The angle made by the mirror with the normal is 90 degree. Ah, we know that. Why are you telling us that? Because 90 minus theta, and if we add 60 degree to it, we must get 90 degree, right? Right. So if we add these two angles, we must get 90 degree. And you can see 90 cancels out and theta is coming out to be 60 degree. We have solved our question. We wanted theta and we got theta. We can mark option B 60 as the right answer for our question. Here is a question based on three-dimensional imagination. Three plane mirrors are arranged mutually perpendicular to each other as shown in the figure. So here are the three plane mirrors. Wow. Now, if a point object is placed symmetrically between the mirrors, then the number of distinct images formed will be. So we place an object symmetrically between these mirrors. And how many images will be formed? This is the question. We have to tell the number of images. And the options are 6, 7, 8, and 9. What is the exact number of images? Now let's have a look at mirror 3 and mirror 2 only. Let's forget everything about mirror 1. So we have two mirrors and we place the object symmetrically between these two mirrors. So what will happen? Images will be formed. How many images will be formed if we only have two mirrors? If only two mirrors are present, we can see that number of images will be 3. If the angle between these two mirrors is 90 degree, as it is so, the number of images formed by these two mirrors will be 3. Do you remember that? Well, I will recall the case. Let's say we go into 2 dimension and this is one mirror and this is second mirror and this is our object. How many number of images will be formed? This is image 1 right over here. This is image 2 right over here and this is image 3. Okay. Actually, the image 3 and image 4 coincides at the same location. That's why we only draw the third image itself. So image A, image B and image C. What about image D? Image D and image C are at the same position. That's why we only draw image C. Okay? Okay. Now let's have a look in 3 dimension. So we have these two mirrors, mirrors M3 and mirror M2. And we can see the 3 image. 1, 2 and 3. Okay. And where is the object? This was the object. Nice, nice, nice. Now what if we place mirror M1? So mirror M1 will be like this, somewhat like this. Okay. Yes. Now this mirror M1 will reflect the object. So object will be reflected below something over something like this. And now all these images will also act as an object for mirror M1. So these images, they will act as an object and their images will be formed by mirror M1. So what will happen? We will get 3 more images. Wow. So let's just see the situation. This is the situation when there is no M1 and now we place M1. Wow. So we got everything now. Now we can see this is very symmetric and we are getting a sort of cube over here. Cube of images. Okay. So this is what we are getting. And now how many images are there? Actually, you can see 1, 2, 3, 4, 5, 6 and 7. 7 images are present. And what about the 8th one? That is our object, not an image. So we are getting 7 number of images. We can go and mark option B as the right answer for this question. Let's see this interesting question. 2 mirrors are inclined at an angle of 30 degree. Can you see the mirrors? Yes. They are inclined at an angle of 30 degree with each other. Nice. Now an object is placed making an angle of 10 degree with mirror M1. So this angle is 10 degree with mirror M1. Good. and the position of the second image formed by the mirrors M1 and M2 with respect to mirrors M1 and M2 respectively will be. Now many images will be formed. Now we are not concerned with the first images formed by these mirrors. We are not concerned with the first images at all. We are concerned with the second images. So at what angle we will find the second images from these mirrors. So these are the options. Now you know one angle is 10 degree and the total angle between the mirror is 30 degree. So the other angle which the object is making with the second mirror must be 20 degree. Nice. We know that. One angle is 10 degree, another angle is 20 degree made by the object from these mirrors, right? With that, we will begin. Now let me show you a general case. Let's say there is an object at P and the angle made with the mirrors are alpha and beta respectively. Good. Now I will show you an awesome table. One column deals with image angle made from mirror M1 and another column is dealing with image angle made from mirror M2. Okay, so here we will write the image angles. Now let's quickly form the first image from mirror M1 itself. This is mirror M1 and we can see this is our first image. What is the angle made from mirror M1? It is equal to alpha itself. Why these angles are same? Because we know that object distance is equal to image distance, right? So we can see congruent triangles and therefore these angles must be same. That's why we take these angles to be same. Awesome. Now we just saw that angle made from M1 of the first image was alpha. This is our image I1. Now let's look at the image formed by the second mirror. This is the second mirror and the image from the second mirror is I2. What is the angle made from M2? The angle made from M2 is beta. Nice. So now let's concentrate our attention on I2 itself. This I2 will act as an object for mirror M1. I will repeat that. This I2 will act as an object for mirror M1. Yes. Now, at what angle are we finding this so-called object? What is the angle made from M1? You will say it is alpha plus 2 beta. Yes. So the image from M1 will be formed at an angle of alpha plus 2 beta. So at this angle, we will get the image and this angle is made from M1, right? Alpha plus 2 beta. In our question, do you remember what was alpha and beta? Yes, we do. Alpha was 10 and beta was 20. Yes. So alpha is 10 and beta is 20. So 10 plus twice of 20. This is coming out to be 50 degree. Good. 50 degree. This is the angle of the second image. Yes. Now, let's concentrate our attention on I1. This is I1. Yes. This I1 will act as an object for mirror M2. So, what is the angle made by I1 from M2? We can see it is beta. It is beta plus 2 alpha. Yes, beta plus 2 alpha is the angle made. And we can see image will also make an angle of beta plus 2 alpha from mirror M2. This is the angle made from mirror M2. Now you know what is this alpha. Alpha is 10 degree and beta is 20 degree. So 2 times of 10 plus 20. This is coming out to be 40 degree. We got the answer. One angle is 50. Another angle is 40 degree. Nice. And also, I will not stop at this. Let's concentrate our attention on I12. Yes, this I12 will act as an object for mirror M1 and you can see the image right over here. Yes. This is the angle made by the image. And now, let's concentrate our attention on I21. This will act as an object for mirror M2 and this will be the image. Okay. So this is the angle made by the image from mirror M2, and this will continue on and on. But I don't want you to continue till infinity. Just stop when the angles are near 180 degree. So you must consider the angles less than 180 degree. Otherwise, it would be a problem. So please consider the angles less than 180 degree. This is my suggestion. Now I will give you a quick way. Quick way if you don't want to see the diagram at all. Suppose you are not fond of diagrams. You just deal with numbers. So there is a quick way out. What is the quick way to draw this table? Here is the quick way. The angle between the mirrors, let's say this is theta. Okay. This is alpha plus beta basically. Now what I will do, I will start with alpha and I will start with beta. From these, I can get the entire table. How? I just need to add this theta. Let me show you how to add this theta. So alpha was on this side. It will go on the other side when alpha plus beta gets added to it. So alpha plus beta, this is 2 alpha plus beta. And see beta is on this side. So it wants to go on the other side. So as it goes, alpha plus beta gets added to it and it becomes alpha plus 2 beta. Yes. And this will continue on and on and on. Wow. So this is a shortcut to get this table. Now, let me just go back to our question. This was our question, and we can see option A. We found option A to be the right answer for our question. Suppose you are not fond of diagrams, you just want the table, you can begin. So one angle was 10 degree and another angle was 20 degree from the mirrors, right? Right. Now what we will do? We will just add the angle between the mirrors. This was 30 degree. So 10 degree goes on the other side. 30 degree gets added and it becomes 40 degree. Nice. And 20 degree wants to go on the other side. 30 degree gets added and it becomes 50 degree. So we got the second images, angle made by the second images from the mirror, 50 degree and 40 degree. We can mark option A as the right answer for this amazing question. So this was the last question of our discussion. Thank you for watching.